Sugarcane production begins with the choice of cane varieties to be planted, based on local soil and climate conditions. Choosing the right varieties ensures productivity and resistance to disease. More than 600 varieties have been developed. The use of fertilizers is limited because solid residues from sugarcane processing are used in the fields to offset traditional fertilizers. Filter cake, for example, rich in phosphorus, is recovered at the mill and utilized as an organic fertilizer. Residue samples are first analyzed in a lab to determine the volume that can be applied. Once the exact contents are known, the residue is loaded onto trucks and carried to the fields. Another residue of sugarcane processing is known as vinasse. Its contents are rich in potassium and other nutrients. Canal systems are often used to carry the vinasse to various points in a cane field. Applying vinasse as an organic fertilizer is a process known as fertirrigation. It reduces the use of petroleum-based fertilizers, which cuts down emissions that contribute to the greenhouse effect. Biological techniques are also widely used in cane fields. Natural enemies are introduced to fight pests and disease, further reducing the use of industrialized chemicals. Once it's cut, sugarcane is highly perishable and needs to be processed in a mill as soon as possible to avoid losing its sugar content. Most cane is delivered to a mill less than 24 hours after harvesting. At the mill, once the truck is weighed, a sample of cane is removed and analyzed in the lab. The sucrose content in the cane determines how the industrial process will be carried out. And sucrose levels can reach 150 kilos per ton of sugarcane. After the truck is weighed and the testing concluded, processing begins. The cargo is transferred to conveyor belts that carry the cane to the crushing system. Cane that was cut manually is first washed to remove impurities. The water is treated and reutilized. The cane is then chopped up and readied for crushing. Sugarcane harvested by machines is cut into small pieces by the harvester and skips this phase. After the crush, either by rollers or a diffusion system, what's left of the cane stalk is known as bagasse. The juice that results from the cane crush is used to produce ethanol. Ethanol is produced from sugarcane juice through a fermentation and distilling process. The juice is first purified by various filtering processes until it is ready to be fermented and mixed with yeast. At this stage, the liquid is called fermented wine. The alcohol contained in the wine is recovered in distillation and rectification columns. Hydrous ethanol is produced at this point. To obtain anhydrous ethanol, The type that's mixed with gasoline, the liquid undergoes an additional water removal or dehydration stage. The entire procedure from the arrival of the cane at the mill to the finished product takes 15 hours. 1 ton of sugarcane yields about 85 liters of ethanol. Once it's ready, ethanol is kept in large storage tanks until it's sold. Top international destinations for ethanol are the United States and the European Union. The most common way to transport ethanol is by truck. Those equipped with flex-fuel engines use pure hydrated ethanol, while gasoline-powered vehicles use anhydrous ethanol, which is blended with gasoline sold in the country. Bagasse is the fibrous residue that's left after sugarcane is crushed. 1 ton of cane produces about 250 kilos of bagasse, which accumulates quickly. Large dunes of bagasse are a typical feature of processing mills. A system of conveyor belts transfers the bagasse from its storage area to generate renewable electricity, or bioelectricity. Control centers equipped with the latest technology monitor the electricity produced, utilized, or exported by the mill to national distribution grids.